Continuing with the numericals that we have been doing, here we have to again find the resistance between A and B, equivalent resistance. So let's say the current enters at this particular point. That current will flow through 6 ohm, and at this junction, the current will get divided into I1 and I2. So again, as we have discussed previously, the same current I1 flows through all the 3 resistors over here. So therefore they are in series. By now you should be comfortable in identifying resistors in series. Okay, so this will be 42 ohms. And here you have I2 flowing through the 7 ohm resistor. So if I redraw the circuit, you have point A, you have the 6 ohm resistance, then you have the 7 ohm resistance over here. This is point B, and there is 11 ohm resistor. Now what we have got is all these 3 resistors effectively work as 42 ohms. So now this should be very easy to identify that these two are parallel to each other. So they are resistance. Now since I've used R1 already, I'll call this as R2. So that is 1 by 7, 1 by 42. So this is 6 plus 1, 7 by 42, that will be 1 by 6. So we get R2 as 6 ohms. Now what is R2? R2 is the effective of these two. So instead of having 7 and 42 in parallel to each other, we'll just have 6 ohms over here. Now what we have? We have these 3 in series. So that will be the final resistance, that is 6 plus 11. Okay, so that will give you 23 ohms. Okay, any questions? So this is diagram number 1. This is diagram number 2. Diagram number 1 should be easier now. We have current I, and as you can see at this junction, the current is getting divided into 3, I1, I2, I3. And this same current I1 flows through these two resistors. Okay, so that means these two are in series. I2, the same current I2 flows through these two. So 10 and 5 are in series, and 20 and 10 are in series. So effectively, we have 3 resistors in series. Okay, so that is 12 and 3, that is 15. 10 and 5, that is 15, and 20 and 10, that is 30. So therefore the effective resistance is 1 by 15, 1 by 15, and 1 by 30. So this is 2 plus 2 plus 1. And therefore you get R as 6 ohms. Okay, so 6 ohm is the effective resistance. Now, this is a very interesting circuit. Okay, something which is so easy has been complicated to confuse you. Let us call this point as C, and let us call this point as D. I'm showing you 3 resistors which are parallel to each other. Okay, so and let us call this point as C and D. That means resistor 1, okay, which is 24 ohms. So one end of the resistor is connected to C, and the other end is also connected to D. you can see that there is no resistor over here. So it is as good as connecting it to D. Then we have the second resistor, that is 12 ohms. Again, one point of that resistor is connected to C and another point is connected to D. And our third resistor, which is again 12 ohms, it has one point connected to C and other point connected to D. So these three resistors indeed are parallel to each other. So the effective resistance will be 1 by 24, 1 by 12, and 1 by 12. So this is 1, 2, and 2. So this is 24 by 5. 5 fours are 20. So this is 4.8. So now this is 30, 30, and whatever this whole thing is 4.8. So it's like 30 ohms, 4.8, and 30 are in series. So that is 64.8 ohms is the effective resistance. Okay. Fine. Now the next what we will do is we'll introduce a battery in it. Or let's before going to that, let's do these questions. I'll do one of them. Like over here in question number 13, I have given you that the effective resistance is 5.6. Okay, and you have to find the value of A. So this we have to find, and this whole thing is 5.6 ohms. Okay, now what you have to understand in this is that what is the circuit telling you? So you have a 2 ohm and you have whatever this will offer to you. Let's call that as R1. So they are in series. So 2 plus R1 is offering 5.6 ohm resistance. So that means what is R1? R1 will be 3.6. Okay. So means 1 by 6 plus 1 by x is 1 by 3.6. So what is 1 by x equal to? 1 upon 3.6 minus 1 by 6. Of course, now it's a math question for you. You can solve it the way you like it. You can make this 10 and 36. So if the 36 is in the denominator, this will be 10 minus 6. 4 by 36, that is 1 by 9. So the value of x is 9 ohms. Okay. So this is a way you may get questions where you will have to find the missing or the the resistance which is missing. Okay, and there can be some questions like this. There are 3 resistors of 2 ohms. So you have got 2 ohm, 2 ohm, and 2 ohm resistor. You have to connect them so that you get a total of 3 ohms. So how can you connect it? If you connect all of them in series, okay, let me show you here. If you connect all of them in series, you get 2, 2, and 2. So 2 plus 2 plus 2, you will get 6. If you connect all of them in parallel, so 2, 2, and 2, so you get 1 by 2 plus 1 by 2 plus 1 by 2. Don't forget on the right side, it is 1 by R. So that is 3 by 2. So R is equal to 2 by 3, 0.67 ohms. So that's not 3 ohms. So what do we do? One another way is something like this. Okay. One more way is this, like you're using three resistors. Which of them is correct? Let's find out. So this is 2, 2, and 2. So these two are uh, in series. So they give you what? A 4 ohm and a 2 ohm. So the effective is 1/4 and 1/2. So that is 3/4. So R is 4/3, which is 1.33. Again, that is not what we want. What about this? So when you have 2 and 2 in parallel, so 1/2 and 1/2, that is 1. So R is equal to 1 ohm. And here this is 3. Sorry, this is 2. So 2 plus 1, that is 3 ohms. That's the answer. So you connect two parallel and series with 1. So the question has asked you to draw a diagram. So you have to draw a diagram like this. Okay, so these are the type of questions that can be asked for your only resistor combination. They can give you combinations and you have to find the effective resistance. They can give you a missing resistor, or they can give you some resistors and then ask you to find the effective resistance. Okay,